Oops. I guess I wasn't live. So all of that, yeah. So all of that I'll have to just re-say that I said that it apparently wasn't on camera. Okay. So the slides are in Discord. The updated slides for today. So you can pull those down and look at those. As we go through here, we covered the first half of this basically last week. I've changed the slides since then, so definitely pull down the updated ones. So went through the first part of this talking about DAOs and the room database and how that hooks up with SQLite. But today we want to talk about LiveData, ViewModel, lifecycle, these architecture components that kind of make it easier to keep the data up to date and reduce the amount of times we have to query the data. So this is going to do a lot of things when we're working with databases or whether we're working with network resources, meaning that we really have to hit them less often, rather than having to say, well, every time we go to a new activity, that's a database call, and we can kind of store things in a more longer term fashion. So that's kind of where we're going today as kind of an overview. Once we finish this, I would say I recorded the rest of the hands-on test review this morning, so that is posted. So once we finish this, I would recommend going and watching kind of the rest of the hands-on test review. You should be able to get through most of that pretty quick. There are some just different comments, different ways to do things that are in there, so I would recommend kind of doing it, even if you think that maybe you have everything in place. You may find some new things in there anyway, some new details. So definitely go through the hands-on test review. And then tomorrow, I want to go through a practical with the stuff that we're covering today. So the plan is by the end of the week, we'll basically be done with all of the lecture, all the theory, and all the practical exercises for 10.1. So next week, you guys have some more time to finish up the chapter lesson 9 and the lesson 10 labs, where we're at with that. And then we're basically getting started with the final project from there. There will be one more written test and one more hands-on test on both lessons 9 and 10. So we'll kind of talk about the details of that next week. Any questions from there with kind of where we're at in the process? Yeah, I'm hoping to have the test grades posted this week. So for lesson 10, we're just going, there's the two code labs, 10.1a and a 10.1b. Those are both on the code lab site. We've worked through part of the 10.1, the 10.1a, and I hope to finish the rest of 10.1a this week. So most of the lesson 10 labs will be kind of in-class practicals. The rest of what I really expect you mostly to do from lesson 10 is to kind of work towards your final project. That's rather than giving you more labs to work on the lesson 10 material. I'd rather have you put that effort into your final project and learning how to use the room database and all these kind of pieces. Does that answer that question, Essen? Yeah, so you'll work through the 10.1b after we finish the 10.1a. So that'll probably be next week that you'll want to work through 10.1b, because it'll be either Thursday or Friday that we finish up with 10.1a, I think. All right. So what we've talked about so far, we talked a little bit about an overview of what the architecture components are. We talked about entities, we talked about DAOs, we talked about room database. We haven't talked about the other things over here, LiveData, ViewModel. We talked a little bit about the repository, but I'm going to revisit that and recover that today. And then the life cycle. So most of the stuff that we're covering on this side really follow into the architecture components. So we really talked about primarily the room database so far. So what we're going to cover is the architecture components. And just to kind of rehash on that, they're just the set of standard libraries that we can use to structure our code in kind of a standard, testable, stable way. You don't have to use these in the sense of you can build applications, and we've done it all the semester without these, but they can make your application more testable as well, especially when it starts to get larger. If we're only talking about, 2-3 activities, these won't necessarily save you a whole ton of time. But as your application grows, these will start to, and as it gets more complicated, these will definitely save you time at that point. So that's the thing to kind of keep aware of. This may, at least at first glance, look like, well, it's adding a lot more boilerplate, a lot more architecture, maybe over-engineering it to some extent. But it's really intended for applications at a larger scale. So that's the thing to keep in mind. This stuff may not seem all that helpful at the scale of applications that we built so far, but at the larger scale of production level applications, real world applications, and what I might expect from you from the for the final project, these can definitely be helpful at that scale. So let's talk about LiveData first. Let's see, do I have let me find the overarching structure. Here we are. So we talked about kind of this area down here. So what we're going to be talking about today is kind of this area up top. So we've got the UI up at the front, which is our activities, our fragments, our views. That's what the user actually sees, and that's where we've lived most of the time, this course. And then beneath that, we've got this sort of view model, which is kind of going to be a container for LiveData. LiveData doesn't necessarily live exactly down here. It kind of lives in all of these levels. The LiveData is kind of going to live a little bit in the view model, the repository, and the database level. So we'll go through that, and then we'll talk about how that connects to the repository underneath that. So this is kind of the area that we're looking for, is that area up top. So the first piece of that we want to talk about is the LiveData class. So LiveData kind of sits there. It's somewhat inside the view model, at least in that diagram, but really is usually owned at a much lower level down in the database owns it, or your whatever thing is that providing the content or the data is usually going to be what owns it. The view model just has a way to kind of get to it. So LiveData is what we call, basically it's a holder class. It is aware of lifecycle events. So for instance, when your activities get created, destroyed, started, stopped, resumed, pause, and it can actually respond to those events and say, okay, well, here's updated data, or, oh, okay, so you started, so I need to go get new data. So it is able to respond to those kind of things. And it's good for keeping your UI up to date with whatever the latest and greatest data is. So the way that LiveData works is that it is observable. It follows what we would call, kind of in the software architecture world, we would say that it follows the observable pattern, or implements the observable pattern. So we're able to observe that LiveData object for changes. So whenever that data changes, we get an event. We kind of can hook up a listener for that and say, okay, when that data changes, then do this. So more specifically, that usually means when the data changes, update the UI. So rather than responding to individual, like, we still respond to button clicks and menu items and things like that, but when we're updating the UI, we might say, okay, when the data changes, update the UI, which is kind of an interesting way to look at things. So the LiveData is kind of, again, lifecycle aware, so it does know when those lifecycle events happen, which is kind of an interesting sort of thing. We'll talk about the life cycle class towards the end of it, and that may explain a little bit of how that works kind of underneath the surface, how it's able to do that. It knows, because it's aware of life cycle events like that, it knows when your device rotates. So it knows when your language changes. It knows when there's configuration changes like that, which normally would typically cause your activity to get destroyed and recreated, or it knows when your activity is kind of not running, or kind of in the background, so that it doesn't update the UI while the user's not even seeing it. So it allows you to do a lot of things. It allows a lot of kind of optimizations, allows a lot of things there, because it's aware of the life cycle. It's not just a plain old Java object per se. But it's also not, LiveData is also not an activity, it's not a fragment, which is kind of interesting. So we can, as far as working with the LiveData, we can observe it, and in that observer we can say, okay, when the data changes, run this code, and basically update the UI anytime that happens. Okay. So if I want to create a LiveData object, at least working with the Room database, it's actually really simple to start with. So when I want to have the database return a LiveData object instead of a list, or instead of the raw data, so here we have, originally we had written this getAllWords method in our Word database. We'd written it as list word. It just returned a list of words. But if I want to have it, if I want to have it return a LiveData object, I literally just say, well, it returns a LiveData object, and Room will automatically generate the necessary code to create and manage that LiveData object. So what that means is, if I ask for that LiveData, originally it's going to come back as null. Originally the list that's in there is going to be null, and then it will make that SQL query and then put the data into that LiveData object when it's available. So I ask for that LiveData object. Initially, I'm probably going to find null in there. And then when the data actually changes, when the data actually becomes available, I'll observe that and listen for that. I'll get that data. So rather than needing to make an async task for this, for instance, I can just create an observer that listens for when the data arrives. So the upside of that is that it makes things a little bit simpler. It means that I don't have to manage as many async tasks, but it also doesn't necessarily make it easy. It also does make it a little bit harder to know when something goes wrong, because this also doesn't necessarily give you a way to see exceptions. So exceptions then have to be managed in a little bit of a different way. So there's that. That'll make that easier. The other thing that this actually does, anytime there's say an insert, an update, or a delete on the database, it will automatically update the LiveData object. So we don't have to say, oh, when I just inserted a row and now I have to update the data on UI. That part happens automatically because I'm using this LiveData object. So I don't have to manually update what's on the UI. As long as it's hooked up to this live data and I'm observing for changes on that live data, watching for changes, basically I just say, okay, there's a new list, let's give it to the adapter and we're good to go. So we can, when we're working with Room, it really will generate a lot of the code that goes behind updating that live data object. If we are working with, say, Volley or other network utilities, working with a Facebook database or an eBay sort of API, any sort of API there, we're going to have to manage it a little bit more ourselves. We'll have to kind of write the code behind the live data to keep it up to date. But when we're working with Room just does it. Okay, so we do need to know a little bit about how it works in order to hook up web services and web APIs and such, but we don't have to really do too much with it when we're working with the Room database, which is nice. So as we're working with live data, one of the things that we have to make sure that we do is we have to pass that live data object through all of the layers. So at the bottom we have kind of the Room database and the DAO objects. That's what initially returns that live data object. So you remember I had that get all words method and it says I return a live data of list words. So that originates down in the DAO. We're then going to put a ViewModel on top of that, so that ViewModel also has to return the live data so that the UI can respond to that. And then we also need to include that live data object kind of in the repository, because the repository kind of sits there in between the ViewModel and the DAO. So passing that through the layers, assuming that all we have is a database, might look something like this. So down at the DAO side, we're going to define the get all words returns live data. So that'll let Room go ahead and build the code on that end. In the repository, we'll then have to ask for, we'll call get all words, and that will give us a live data object, which we'll then save. And then same thing on the ViewModel, we'll then have to call down to the repository and save it as a live data object. If we save it as a list, if we just have it as a list of words, we won't, at any of those layers, we won't be able to observe it and watch for changes. So if we want the UI to be able to observe it, it has to be a live data object the whole way through. So in terms of observing that live data, typically we're going to start that observer in the onCreate method of our activity. Inside of that observer, we need to override the onChanged method, and that's where we're going to actually put the logic to update our UI. So if the data changes, that onChanged method gets called or gets notified, and that's where the code executes. So looking at kind of an example of this, let's say I have a model, this could be probably a ViewModel. We're saying get current name. Well, get current name in this case returns a live data object string. Okay, so that's a string that's basically observable. And then we're going to say observe that live data object. We wouldn't be able to call this observe method here if this get current name just returned a string. So it does have to return a live data object if we're going to observe it. So there we'll say, okay, observe it, pass it a context, and here also pass the observer that we want to use to watch for changes. So here I'm saying, here's my observer that I've created. So I've said this is a new observer object, and it watches a string, right? So here I'm watching a string. If I was watching, say, a list of words, then this would be list word here. It's whatever data type you're watching, okay? And then in here on changed, I get the new value. It will give me the new value of that live data object, wherever I'm observing, and then I just need to update the UI. So here I'm just going to display the name in a text view. So I say, take that text view, call set text, put the new name in there. So that's kind of a simple case of what it might look like with observing a string, a live data string. If I was observing live data, like a list of words, observing that get all words, then that would be, this would be, I'd get a list of words. It would be that new list, and then I'd need to update the adapter. So I'd do adapter.setItems and give it that new list. So one of the many kind of upsides of using this live data object and the lifecycle object that kind of underlies it is that they're bound to the Android lifecycle, and they clean up after themselves anytime that lifecycle is destroyed. So that really helps with memory leaks. It means that the listeners are hooked up at the appropriate time, and then they're unhooked when the application stops or the activity is stopped or destroyed. So that we don't have to put nearly as much logic into our activities, actually. This does extract a lot of the logic that we might normally write into the activity, especially the on stop and the on destroy methods to do some cleanup. A lot of that can happen now with these live data and lifecycle objects. So one thing to know about how live data works, live data does get all of anytime you change the data, it will receive those changes. It will go ahead and save the new data. But the way that lifecycle's hooked up, the way that live data works, if your app is running in the background or your activity is running in the background, it won't actually update the UI. So let's say you're on the settings screen and it gets a notification that your list of articles has changed. Well, okay, it'll save that, but it won't actually show the new data until you return to that screen. So it means that it's not spending a lot of time and resources updating the UI when the user isn't even going to see it. So that's a big benefit to using this live data, as well as using kind of a lifecycle object that's behind it. So that's one benefit there. It also is able to deal with configuration changes. So, for instance, if you turn the device from portrait to landscape, typically that means, well, okay, you're going to completely destroy the activity and create a new activity. If we're using all the tools that we've used before, typically that means we're forced into kind of re-querying the database or querying the network again, just because the user did a rotation, and that can be pretty jarring. It can be a lot of extra resource or network utilization that we maybe didn't need to do. So live data does persist through those configuration changes, through those orientation changes. So just because you turned the phone on its side doesn't mean that I have to go get all the words from all the records, all the articles from the database again. I just use the values that I had before you turned it on its side. And so it doesn't have to go requery it. It'll just show the data it had when it comes back. The other thing that live data allows me to do is it allows me to kind of share resources between different parts of the application. So for instance, if I want to access that words database, if I want to access it both in an activity, both main activity, and in some sort of job service, I can easily access it in both places without requiring additional queries to the database. So I can get access to the same live data that's being used on both sides. So that's great. It also allows me to connect a lot of different system services together. That can be, it can sometimes that is things that come from a root database. Sometimes it's things that come from the network. Sometimes they may come from other sources. I mean, maybe I want to hook some data that's coming in via Bluetooth or NFC into a live data object. That can happen. So that live data can really come from anywhere. But it's designed for sources that are kind of external to your application or kind of take some time to get. Typically requiring some sort of asynchronous source or different parts of your application can change. It's really good at managing that. Now, one thing you can also do is extend the live data object if you have a special sort of case. Let me follow this link right here. So one of the examples that they give is, so here's kind of, let's say we have some stock data. And we're kind of watching the current price of a given stock. So I want to say, okay, given the symbol, I want to know what the current price of that stock is. So let's say we're watching AMD stock, right? So I'm going to give it the AMD symbol. I'm going to create a stock manager that I'm going to use to watch that. And then I want to say anytime that updates, let's update this live data object with the new data, let everybody know about it. So here I'm kind of creating a subclass of live data that contains a big decimal. And we're calling it stock live data. So this is for a particular ticker. And then we say, okay, well, let's create this stock manager object, which in theory is able to go and get and monitor what the current stock price of that is. That might be implemented through some sort of network call. It might be implemented through a lot of different methods, but more than likely there's some network code behind that. But the good news is here we don't really have to know about that. So we're saying, okay, let's get a stock manager, and then when this live data becomes active, which is say when it's either started or resumed, when the activity is started or resumed, then we'll tell the stock manager, okay, we are interested in price updates. So hook up our listener object. So as long as the activity is live, we do want to hear about changes. And then when it becomes inactive, say the activity goes into kind of a background state, the user's not seeing it because it's either paused or because it's stopped, then we'll remove the listener and not be listening for updates. Okay, and we've got kind of a listener here. So this simple price listener just says, okay, here's their on price changed method. In theory, this simple price listener is something we've created in another class, same way with our stock manager. So that just hooks up to the stock manager and says, okay, well, when there's a change to the price, then change the value of the live data, which then the observers can see. Yeah, so it doesn't necessarily fully mitigate the need for broadcast managers or broadcasts. You still want broadcasts for things like device changes, but it is kind of another way to do some of those things that we might do with a local broadcast or a local for broadcast receiver between things like that. So, for instance, if the job service needs to kind of update the data, rather than sending a broadcast through from the service to the activity can be listening to this live data, which is then updated kind of behind the scenes as the job scheduler is working with it or the job service is working with it. So yeah, it does become one way to pass data effectively or for the service and the activity to both see the same data. So yes, some cases where broadcasts make sense, you can then sub this in and this will actually be better. The other thing is when you're doing this, say you want to send data through with a broadcast, typically you would need to serialize that data or make it parsable, serialize it, save it, and then send it through as part of that broadcast intent. But with this live data, I don't need to serialize the data along the way. It's just in memory. So we put the data in there in the service, and we read the data out in the activity. So that can make things a lot more performant, especially as we're dealing with we're dealing with more data. Is we don't have to do that serialization and deserialization. So that's kind of where the live data fits in. And you can see that you can do a lot more things there. What you kind of saw with the stock manager is a similar thing to what we can do with Volley. We can make our own kind of live data subclass to listen and manage things there, potentially. Any questions right now about live data? No. So the upside of this is you don't need to use at least as many tasks. You'll still end up needing to use tasks to do like inserts, updates, and deletes. But for select queries, this kind of removes the need to have that async task to get the data. You still have to hook up an observer to get the data when it comes back, but you don't need an async task for, say, getting all the words now with that. One thing I might mention before we go on to the next pieces, live data can really be used on its own. You don't have to use live data doesn't have to be used with the room database. It doesn't have to be used with a ViewModel. It doesn't have to be used over the repo. You can use live data really in any application by itself. The only reason that we're talking about these things together is that they really do work well together, and they've been built to be integrated with each other. But you can use live data without all of the other stuff in this lecture, without all the other stuff in this chapter. Same way you can use room database without all the other stuff in this chapter. So let's talk about ViewModels. So ViewModels are generally kind of the piece that that directly face the UI. So typically the UI is going to be directly interacting with the ViewModel. It's where it's going to get the live data, and it's where it's going to get the interact kind of indirectly with the repository. So it doesn't know all the details kind of underneath. So the ViewModel is really the only class typically that your activities and your fragments will see. Everything else, all the repository, the room database is typically behind this ViewModel. Okay. So this ViewModel's not exactly like the ViewModel that we talked about in third semester, where it's kind of the interface between the controller and the view. There is kind of some similarity there in some sense, because it kind of sits in the same place. If you think about the repository being the controller and the UI, the fragments, the activities being the view, it sort of sits in that same place. But the point here is this is kind of a stateful interaction, whereas what we talked about in third semester, things were stateless, which is a normal web kind of framework. This really relies on the idea that things are stateful. State is maintained from time to time, from time point to time point. So that's an important thing. So the goal of the view model is to provide the data to the UI. Okay, the view models are designed to survive configuration changes. So if you turn it left and right, that view rotate the device, it'll survive through that. Same thing with language changes and other configuration changes. It'll survive through those things. You can also use the view models to share data between fragments and activities and such. Which can be a little bit of a gotcha in some cases, especially because fragments are typically not lifecycle aware. They typically don't know what's going on outside of what they're displaying. So that can be helpful for managing things. These are, again, part of the lifecycle library, same way that LiveData is also part of the lifecycle library. So with the view models, surviving lifecycle change. So you have an activity instance, you do a rotation, remember that triggers a configuration change, and then that means that the activity gets destroyed and then recreated. Well, both of these can be connected to the same view model object. We don't have to recreate that view model object when the configuration changes, even though we do have to recreate the activity. So that can save us work in terms of not having to get all the data or rebuild all that data. It also means that we can typically survive or go through a rotation change without having to save it to a bundle through like save instance state and then restoring it in onCreate from that saved bundle. So that's actually can be a big boon. It means that your rotations happen a lot faster. There's not as much lag between changing rotation or changing language because it doesn't have to completely throw it all away and start over. It can reuse the data that's in the view model. So the goal of the view model is to serve the data to the UI. So there's kind of an analogy over the next few slides that we talk about here. If you kind of think about it from a restaurant side, our view models are kind of like our servers. Okay, we say let's say the UI is their customer. Right? They're the people that are actually seeing and receiving that data or that food. And our server, its job is to ask, find out from the UI, what data do you need, and go get it from go tell the chef to make it, bring it back. So their job is to go and interact with the kitchen and end up bringing back the food for you without the customer having to know anything about what happens in the kitchen or have any connection to it. So that data could be coming from a room database. It could be coming from any other source, whether it be you might have a job scheduler involved. You might have some sort of network queries, whether it be through like Volley or other tools that you can retrieve network resources, or just using basically it could be from files. It could be from settings. It could be from settings or preferences. It could be from Bluetooth. It could be coming from anywhere. The idea and the goal is to hide those details from the customer or the UI. So it just knows, okay, I've got new data, I'll show it. That's all the UI has to know. So kind of recommended best practice with the view model. It's really strongly recommended to use a repository, which we'll talk about in a minute in the next section. So the repository really does the work of getting the data, modifying the data. You can think of the repository as kind of being the kitchen. So the kitchen is what knows to actually get the data where it is and how to listen for changes and how to work with all the different protocols that go into that. The server or the view model, all he knows is how to kind of talk to the customer, take those instructions to the repository, and then when the repository says it's got new data, then to bring that updated data to the customer or the UI. So it kind of sits in between there and provides a kind of a clean interface between the two. Okay, so if we're thinking about this server or restaurant analogy, kind of dive through this. The terminology that we're using here, we're saying that the customer is the UI. We're kind of saying that we're going to treat the server as the view model, then the chef is going to be the repository. So if we say in kind of a restaurant sort of area, the customer asks for a meal, they say, I want the nachos. I want the nachos. And so the server takes that order, takes it to the kitchen, and tells the chef that the customer wants nachos. And then the chef they make the nachos. They prepare the meal. And then once the nachos are done, or once they're ready to be eaten, then the server delivers them to the customer. Okay, so you can kind of map that over to how things work with the repository and the view model. Basically, we're going to start at the front. The UI first requests data from the view model, says, here's the data that I want. The view model then says, okay, I'll get that data from the repository. Repository is basically the chef. So repository then figures out what that data, cooks their meal, cooks their nachos, and then the repository says, hey, your meal's ready. And the view model then gets that data back to the UI. So there's a few different layers here, but the one that the only one the UI directly interfaces with is the view model. Okay, so an example view model might look something like this. We're going to create a Word view model class. We're going to say that extends an Android view model. Okay, we have a few different properties here. So it has a Word repository. So it has access to the repository, and it also has this LiveData list of words, ML words. Okay, so we create the constructor for this object. It needs an application and a repository. An application we're going to pass to the super constructor, and that basically deals with hooking up all the lifecycle sort of events with creation, destroying, etc., so it can hear those things and handle them appropriate. We're going to save the repository that we're given, and then we're also going to go ahead and ask the repository for all the words and save that for later when the UI wants that list of words. So a little bit more in this class. So now we have a getAllWords method, a getter. That's just going to return this ML words. You'll notice here that I'm returning LiveData. I'm also saving it as LiveData. That's important because if I just have it as a list, well, then every time I call getAllWords, it has to go get it from the database. So LiveData manages that, so it only has to do it less frequently, like when there's changes or the first time you ask for it. Just be forewarned that maybe the first time you ask for it won't be there. It might be that actual list there is null. So you'll have to observe that live data to know when the list is actually there. Okay, but you don't have to use a task to do that observation. It's already dealing with the background threads and things like that. Now, let's say I want to, for instance, insert a word or delete a word. Well, then I'm just going to call into the repository and call the relevant method. So insert word is going to call insert word on the repository. Delete word is going to call delete word on the repository. One of the important things that I haven't done here and you don't want to do is that there in the view model, there's no way to get the repository. Because if you provided a way for the UI to get the repository, then you're kind of breaking those layers of abstraction. you're giving the UI direct access to the repository, whereas this view model is kind of supposed to sit in the middle. One important note with the view model, you never ever want to store context in your view model object. You don't want to store, and that means don't store activities, don't store fragments, don't store views. Context in any of those objects in any context instance should never be stored in the view model. The reason being, all of those things can be destroyed and created a lot of times or many times during the life cycle of the view model. The whole point of the view model is it should outlive those UI controls. Okay, so if it has access to any of those UI controls, any of those UI components, whether it be activities, fragments, views, then it's not going to be able to outlive the activity. Okay, the whole point is that it's the parts that aren't directly connected to the UI, so it can outlive the UI. Okay, because if an activity is destroyed, all the activities and fragments, the activity, all the fragments, any of the views, they have to go away. There's no you cannot keep those. So that's one big thing that you have to keep in mind. Your view model has absolutely no connection, no reference to your UI. Your UI knows about your view model, but your view model does not know about your UI. If you do need to do anything with context, you'll want to subclass the Android view model object like we've done here. You saw this was a subclass of Android view model. So that does allow us to do some things in response to that may need a context. Say if we wanted to display a toast or things like that, that does allow us to do things like that. So the point of that view model is really one big thing is it's going to survive those configuration changes, but on the contrary, it's also while it does survive configuration changes, it does survive the user going between activities. It doesn't survive the user shutting down the app. If the user shuts down the app, everything in your view model, it's lost. Okay. So it doesn't necessarily replace, it's not really meant necessarily as a strict replacement for, say, on save instance or on restore instance state. Typically, if we're using a view model, that's kind of what we'd consider transient or kind of temporary storage for the data. If we need it persisted from one run of the application to another, then we really do need to save the data either to, say, room or a file or a network resource or settings preferences. And we do need to store it somewhere that's going to live through the app getting shut down or the device getting shut down. So that's one thing to be wary of. Although it kind of does live beyond one particular instance of an activity, it's not a full replacement for some of the other tools that we may have covered already. A lot of times it can kind of do a better job than some of the tools that we've given, but if it comes to needing the saved data from one run of the application to another run of the application, it won't really help you with that. Or if you need things like, I need to save what the user's typed in on this screen, on this edit screen or creation screen, those kind of things you still want to save to the saved instance state. So let's talk about repositories here in a minute. Before I do that, does anybody have questions though on the view model? So let's talk about the repository. Okay. So the repository is considered kind of a best practice when you're working with the architecture components. It's not really part of the architecture components themselves. So laptop is glitching out. So there's not really per se a repository class that you have to create a subclass of. This is just kind of something that you create to manage different parts. So you can kind of think about, like I said previously, you can kind of think the repository. Oh, my camera did freeze. So let me go touch that. Okay. Yeah, that should be up and running. My dock glitched out, so it kind of shut everything out. Well, everything that was connected to it off and rebooted it, and that's where it killed the camera. So it should be good now. So the repository, again, isn't really part of the architecture components, but it's considered a good practice, a good thing to do when working with these components. So we were talking about the kind of the restaurant analogy. In the restaurant analogy, the repository is that chef. It's the kitchen. It knows how to make the food. It knows where to get the different ingredients and put them all together, and then deliver that food to the server, who then delivers it to the customer or the UI. So it has really no connection whatsoever with the UI. One thing that means, especially when there's errors, it can be a little bit difficult to deliver them from the repository up the chain to the UI. So that's something you do have to think about. How am I gonna, how are you gonna deliver errors up to the UI? You definitely want to log any errors that you run into, for sure. But repository, because it's got no connection to the UI, can't even do things like display a toast. So you typically have to then provide some sort of event or something that event or live data that the UI can then observe and see when there's errors and things like that. So the job of the repository is to be able to fetch the data in the background. So the idea is that for the most part, both the ViewModel and the LiveData don't really know anything about background threads and threading. So any work that you do with tasks or background threads, though all that logic typically gets stuffed into the repository. So the repository does all the background work, and then the ViewModel and the UI just listens for, just observes those LiveData objects, seeing for changes. So one of the advantages of potentially putting a repository in is it can then hide cases where you have more than one source. So for instance, if you have data coming from the network, say it's a JSON feed of some sort, you can have that data. Well, sometimes the repository returns that data from the internet, and sometimes it retrieves that data from the database, depending on whether or not the network is active or available. So it can retrieve it from one or the other. It can also deal with managing those threads. So for instance, code that we write with Volley, we're probably going to stuff a lot of that, basically all the code for Volley, into the repository or into a source that's kind of lives underneath the repository. So the gist is that the repository is making that decision between using offline cache data or deciding to go refresh it, grab it from the internet. And it can really do a little bit of both as well. It may say, okay, well, here's the cache data right now. I'll go ask for newer data and give you that if there's newer data. So simple kind of example of maybe creating a repository class. I'd say public class Word repository. You'll notice it doesn't extend any other class, again, because it's not really part of the architecture components. But it's this idea pattern that we follow typically when we're working with the architecture components. So you can see it's got a variable for the database. You can see it's got a variable for the word DAO. You don't have to have this. The whole point there is to just maybe not ask for the word for the DAO every time we need it. You could ask for the DAO every time you need it. You don't have to necessarily store that into a variable. So here we're saying in the constructor for the Word repository, we're taking an application and a DB object. We just save the DB object. We ask for the word DAO, again, so we can simplify the code beneath it. So we don't have to ask for the word DAO every time we need it, but we could. Beneath that, we then have a few different methods in the repository. So the first one is to get all the words. That's just going to call into the DAO and say get all words. You'll notice that that's, again, returning live data because we need to bubble it all the way from the DAO up to the view model so that UI can actually watch that live data. Again, if we pull it out of that box, if we pull the list of words out of the live data box, then the UI won't be able to observe and watch for changes. So we need to just kind of pass that through. Okay. In this case, the room database is managing updating the live data in the background, which is why this can be called from the main thread safely, is because room is managing that on managing the updates to the live data on the background thread. However, on the insert case, I do need to run inserts, deletes, updates. I do need to run those on a background thread. Because we're not using a sort of a live data object or anything there. So here I'm going to create a new insert task. I'm going to tell execute to insert that word. So my insert task here would look something like this. I say it extends async task, takes in a word, doesn't have any progress event, doesn't have any sort of result. So in here we're going to say do in background. It takes parameters, which is word. We're really only passing in one word here, but if I wanted to say insert multiple words at once, this insert task would still work for inserting multiple words at once. So I loop through the parameters. I say, okay, grab each word and insert it, and then once we're done with that, return null, because there's no return value that I really care about. So this statement here will automatically, because it's hooked up to the word DAO and that you got that get all words that returns a live data object, it'll automatically, once this insert succeeds, it'll automatically update the live data so the UI can just see, okay, a word was inserted when the insert goes through. So I don't have to also trigger an update to the UI. Room will automatically trigger that update to the UI. Okay. Any questions about the repository? Cable somewhere. Cool. Okay, so camera's back up and running. So that's the main parts. And the next part we want to talk about is the lifecycle class. So the lifecycle class has kind of been underlying a few things that we've talked about. You'll remember that a LiveData object is kind of an example of that lifecycle. If I remember right, LiveData is a subclass of lifecycle, as well as ViewModel, I believe, is a subclass of lifecycle. So lifecycle is kind of a generic class that can be used for a lot of different purposes like this. We're not going to really use it directly for most of the things that we do, but there are some cases where you might. And just kind of explaining how is this stuff even working, how is it even able to know about the events that are happening in the activities. How is it able to know the what state the activity is in? So lifecycle methods are kind of meant to extract a lot of the logic that you might normally put into, say, the onCreate and the onDestroy methods and such. You might call it from there in an activity to kind of pull it out and let the framework deal with some of those things. So that means that when we're using these lifecycle aware objects, we don't have to add additional logic to the onStart and the onStop methods, or the onPause and the onResume methods. That can be managed separately. So using this lifecycle class, we can actually make any class be able to react to lifecycle events. Lifecycle aware components, they're designed to perform actions in response to changes in the lifecycle status of another component. Typically, these lifecycle aware components are connected to activities, so the state of an activity. So for instance, you can set up a listener or some sort of callback, yada yada, that responds to, that's listening for when the activity is started and stopped, and starts and stops itself. So it's only sending events or in data to the UI when the activity is actually live. So different cases where you might see this used. If we're talking about, say, for instance, GPS and watching for your GPS location, we can either listen for your GPS location in kind of a fine-grained way, where it gets it down to within a few meters, and we get updates every few seconds about where you are, or we can set it to a more coarse-grained manner, where it says, well, I only care about when your location changes by a kilometer or more, and I only care about getting it at most every, say, 5 minutes. So that might be a coarse kind of location update setup. So if I'm doing something in the background that I don't really care about your exact location, like I'm just trying to figure out, are you at work? Are you at home? Are you at the store? That's usually suitable for a course location update, versus if I'm showing you GPS directions, I'm actively showing where you are on the map, then the user's going to need to have fine-grained location updates. The catch is fine-grained location updates take a lot more resources. It drains a lot more battery. So we want to do coarse-grained updates whenever we can. So using the lifecycle object, we can say, well, only do those fine-grained updates, only ask for fine-grained updates when the user is actually seeing the map. But if it's just in the background, we don't need to do fine-grained updates. We can just work with that. Similarly, if we're dealing with maybe playing some video, we might use the time while the app is in the background to do some buffering, to get it ready, to get more video stored up while the user's not watching it. So I might do something different when the user's not watching it to buffer up more data, but not try to show the data that's currently being played versus when the user's playing the video. It just may change my buffering strategy and such. So similar things with network connectivity. We might want to say, well, let's stop getting resources or stop monitoring the network when the app is in the background, and only monitor for things on the network when the UI is actually, or that activity is actually on screen. So we can do a lot of things like that. We can also pause and resume maybe drawables, images that we're animating. We don't need to animate that. We don't need to animate it if the user is not going to see it. So pausing things similar to maybe how video might work. Okay. So in order to use the lifecycle library, you need to import packages from the AndroidX.lifecycle. Different packages from there. As you kind of saw when we were going through this last week, the different packages that you need kind of vary depending on what you're doing. So for what we did last week, we brought in really these two dependencies. We brought in the lifecycle ViewModel package, as well as bringing in the lifecycle LiveData package. If you don't need either the ViewModel class or the LiveData class, if I remember right, you can just do lifecycle.-core, and that will give you the lifecycle object without the ViewModel and LiveData classes. So depending on what you need, if you need the lifecycle without the ViewModel or the core, or that will change which dependencies you need. But assuming you're doing what we've kind of done here, you want both ViewModel and LiveData. Those are the dependencies that you're going to want to bring in. Just paste those in here for reference. So that's going to provide the base lifecycle class that we can, and other related classes, to make our objects or components aware of lifecycle events. So to work with lifecycle events, we'll need to create a lifecycle observer class. That lifecycle observer kind of follows the typical Android lifecycle of an activity. And then the lifecycle, interesting thing to note on the lifecycle observer class, it doesn't actually have any methods. It doesn't have any methods that we need to override. Instead, it uses annotations to define what methods should be called in regards to the different events. So for instance, if I want to define this method is called in onStart, maybe I call it connect. So connect needs to get called on start, disconnect needs to get called on onStop. I'm going to add this annotation to say, okay, I want to call connect in onStop. I'm going to call disconnect when the activity stops. So I define it with those annotations. I don't define it with by overriding, say, on start or overriding on stop. Okay. You can look at the lifecycle event reference to see kind of all of the events that are available, but those are at least two quick examples of what you can listen to. So, for instance, one example you might do here is you say, well, I want this object to be aware of when the activity starts. So whenever the activity starts, I'm going to show a toast. So here I'm showing the toast initially, and then I'm showing a toast when the device is rotated. So this is being implemented by a class that's kind of behind the scenes. It's the class that's doing this is not a service. It's not a LiveData object. It's not a ViewModel object. It's not any of those things. So I can really make any, but the point is I can really make any object a lifecycle aware object. So here I'm creating an aquarium object. Okay, you'll see that the constructor takes an application and a lifecycle. Okay, we haven't seen where this lifecycle object came from, but just say we have it. In the constructor, you'll notice I've marked both of those things final. In the constructor, we can then add an observer. So we can add an observer to the lifecycle, say new lifecycle observer. Here I've got my connect method, so I say when the activity starts, run this method, run the connect method. Connect method says, let's show a toast with the text lights on for a short period of time. That's it. So this is in the constructor. It now can listen to anytime the activity is started and show that toast. If I want to then use that aquarium object, I go to my class. So my main activity class, I'm going to create a new aquarium, and then I need to pass in, remember, an application and a lifecycle. So to get the application, I just call getApplication. If I had a specific application subclass, I could do that here as well. Pass in that specific subclass. Here I'm just saying getApplication because I don't really care what, I don't have a subclass that I care about. But if I did, I could do that here. So the application, and I just call getLifecycle. This method will return the lifecycle object that's connected to this activity. So that's basically it. I've now made an aquarium that can respond to changes, lifecycle changes on the activity. So I can do that with anything. I could do that with the stock ticker example. I could do that with other network resources. Say I want to get the articles from NPR, from that resource. Say I want to get fortunes from the other API endpoint that we used in a previous lab. All of that stuff could be potentially hidden inside one of these lifecycle aware components. Okay, so that's the end of the slide deck. You can read through the concept chapter for 10.1 to maybe get a few more details there. You can go through the two labs, the 10.1a practical, the 10.1b practical. We've started the 10.1a practical. We did that though just with the room database and not using LiveData and ViewModel. So either tomorrow or either Wednesday or Thursday, the plan is to go through and finish up 10.1a with those additional components. Okay, any questions? Yeah, I mean, we could do the same thing with like the chat application that we did earlier. We could say, let's put the messages into a LiveData object. So I could have a LiveData that's a list of messages, and then connect that up to connect that LiveData object up to the UI. So the repository could kind of hide all the logic that goes into checking for new messages. Okay, so that's all the theory I have for today. That's the last set of slides really for this textbook. Again, what I'd want you to do for the rest of the day is go through the get caught up on the hands-on test review, so that you have that up to date. Get caught up with the Word database example that we did over the last few days, so that both of those projects are up to the place where we're currently at, up to being kind of finished. Because tomorrow I want to go through an example of how to use LiveData and ViewModel with both the Word database and ideally and with the hands-on tests as well. Again, if you have any questions, anything further on this, you can definitely hit me up on Discord. I'll be there the rest of the day. Should you have any questions about the hands-on test or about Chapter 10 and such. So don't forget that you have a few reading assignments on Perusal that you'll need to go through. Make sure you take the time to read through all of those different pieces that I've posted on Perusal. Also, don't forget that you should be spending some time on your project proposal, your final project, and your project proposal, because I think that's due the end of this week is your second draft. So, all right. Stop that stream here.